modeling labs. You'll be using a model for manipulating two variables that affect global climate change and then looking at the outcomes of that as far as the change in global weather patterns and also other types of data that you can collect from this model. Mathematical modeling is very important when we start looking at things like climate change and population change. And I'm not going to make you do a lot of math. I'm going to actually have you change some variables and let the computer system do the math itself. So when you get to the activity, what you're going to be seeing is an overview that you really should read and go through and scroll through this. This is going to be your simulations. When I ask you later to open the simulator, this is the button you're going to be pushing on when you go into the Annenberg Simulated Carbon Lab. Now, you will be viewing the video that goes with this module, but you don't have to do the Habitable Planet assignment. You do not, and please do not, because I think I've assigned enough of those to you right now. But as you go through the lessons, I'd like you to go in sequence of first looking at the carbon cycle in general, and please follow the instructions for step 1 and 2 in this module. You'll just click through these steps as you go along. Then you're going to look at ways that you can curb auto emissions as a way of looking at how do we remediate climate change. So you're going to first become familiar with the model and then apply the model. And in this last one, I'm going to let you play around with this, but this is going to look at something called feedback effects. And I'm going to give this more as extra credit than anything else. So if you just want to do 1 and 2, that is fine, and just be honest and say, I really don't understand number 3, or you can do your best. I'm going to grade very lightly on that and only give points for people that attempt it. I'm not going to take points because this does get to be a little more complicated as we look further and further into this model. So this is what the video is going to look like. So just watch the video, please, because it gives you background for the lab you'll be doing today. The virtual lab or simulation is related to what you'll be learning in this module. And you'll see right here, it's related to the topic of Earth's changing climate. And I'll show you where on the Annenberg website to look for the module if you don't use the direct link in D2L. So I'm going to give you a direct link to the module. So you'll see that the labs are separate than the other modules. So you will be looking at basically the module on global climate change. But then you're going to look at what's called Interactive 14, which is Carbon Lab. And that's going to rely on your knowledge, again, of viewing the Habitable Planet and also listening to my lecture. So I prefer that you listen to the lecture and read a little in the book before attempting this lab, because it is going to require a slight knowledge of principles to understand when you're controlling the variables that I'll show you. Now, something I'm going to ask you to do too is to pull up the data table student worksheet. I gave you the link for this, and we'll just open up as a PDF. If you have trouble, I mean, not as a PDF, as a Word doc. If you have trouble, I could email you a PDF upon request, because, but I don't want to post a PDF in general because for a lot of people it's hard to write on, and they have to scan it. So write directly in the Word doc, and you're going to see as you work through the steps, like step 1, for example, step 2 are delineated here. So in step 1, you'll be using this part of the table to put your answers, and I'll show you where all these answers will be. So you're going to be looking at years at first and look at the gaseous carbon in the atmosphere, which the measurements will be given you. You'll be looking at ocean surface, deep ocean, and this is going to give you information on the chart about this. So you'll read the module to understand what you're going to be putting in this data table. It's important to read the instructions in the module, and there is no instruction book. You read it right on D2L and follow step by step, and you'll go all the way down to lesson 2, which is mandatory. Lesson 3 is not, and you'll see that all on one student data sheet. So please go to the link and open this up first before you start going through the lab, so you can start writing your answers in these little areas. So when you go to this sim first what you need to do is read these steps and then click on the sim. I'll even tell you that in the instructions. And once you're in the sim now, you can go back to and look at step 1 and 2 of curve the emissions in lesson, which is, second part of first lesson actually. And then you can look at the feedback effects a little later, but they all rely on this module. And the module does have different windows for the different complexities that go with the lessons. So again, read first, then have your worksheet open, and then go to the simulator. So just to reiterate the steps, this is going to be your opening window. And make sure you, again, pull up your worksheet, read the steps, go to the sim. Then when you're done with the first lesson, go to the second lesson, same thing, and the third lesson. And again, the third lesson is optional. I'm just repeating this to make sure that you know what to do and you don't get lost while doing the assignment. So please read the instructions. So this is what your sim's going to be looking at. Looking like. This is going to be where you basically measure your CO2. And this is going to be looking at some other variables depending on what you're doing. So you could adjust basically emission rate from cars, and you could look at the change in CO2 over time. Now, when you open up the module, it should give you 2% here and 1 GT here, and you'll learn about what those units are. So make sure when you start this, because when you restart it or do the next module, the numbers will change. So make sure you always set this. You'll see how to set this. It's very easy to do. You set this upper one to 2 and the lower one to 1, so you have the same starting point. So please, if you don't see 2 and 1 in there, change those numbers. You'll be able to see that you can do that by clicking on these numbers or by scrolling these back and forth. And actually, in this version, you scroll these back and forth to change those numbers. Now, they'll also, as you change, you'll see a graph. Now, in the graph, this is going to be basically what's called your normal curve. That means as things go over through time and history, as CO2 is going up and auto exhaust is going up, this curve would follow that. And this is called the theoretical. That means you could look at changing these variables right about the time that we start now and look at what happens to that curve. And I'll show you that in the next slide when you manipulate it. So what you're going to be looking at is, again, this normal curve and seeing what happens to the curve after this point when you change variables, either elevating or lowering CO2 or affecting auto emissions. And this curve can go that way. It means it gets the Earth gets hotter quicker, or you can slow it down or make it stop and even go down, which would be amazing. Now, other data is going to be spit out here. So when you look at the data here, look here too for what to put into your table. This will talk about ocean temperature, CO2 levels. This will look at atmospheric, and this will give you other values too that's explained in the video on how to go through the module, or I should say in the instructions on how to go through the module. So in this side, we're going to start from your starting point. You have 2 there, and if not, move the slider back and forth. You have 1 here, move the slider back and forth. Your graph should look like this, because this is the current state for when this module or this data was collected. What you're going to be looking at now is a change in this from either the same to much less, to less of a curve, or to more of a curve. And pay attention to all the data here at the starting point. I mean, look at all the bars here, and the numbers for all these different measurements that are given in this lab. And then what we're going to do now is shift this over in the next slide. So what I did in this slide now is move the upper slider from 2 to much higher, 3.7, and then I reduced this bar to about -2. And look what that did to the graph. So when you see the graph do this, because it's now going, instead of here, it's going here. And what you have to interpret that as is the Earth over a period of time is going to get warmer than expected by doing that. So that would not be a good thing to do. What you're hoping to do is change it so that this slope goes like that, And it will probably be impossible to do as populations go up, but even make it to the point where we're not increasing the amount of exhaust emissions. So look at the graph, look at the numbers here. You can see changes in all of these numbers too as you manipulate the variables. Again, enter the data to the best that you can. There is going to be no absolute answer depending on what you do with your variables. What I'm going to look for is whether you have the correct, what we call trend. That means if you're increasing that, it should increase this. If you're decreasing that, it should decrease this. And that's mostly what I'm going to grade you on. And also completeness. So have fun with this, because mostly what I want you to get out of this is how do scientists use math in a simulation to look at policies that affect global climate change. And we do this for all sorts of things, types of pollutants. We can look at human death rates on this. There are a lot of things we can put into these type of simulations. So don't fret about it. At the beginning, just play around with it, have fun with it, and then go through the assignment.